Hello students, welcome to another video of the chapter Acid, Bases and Salt. So we will start our discussion from where we left. Okay, so in the last video I think we have discussed till what is the definition of acid, what is the definition of base. Then we came to know about indicators, what are indicators, what is their work, what are different kind of indicators such as litmus, methyl orange, phenolphthalein, etc. So in today's video we will took forward our discussion and we will look into details about some of the key properties of acid and bases respectively. First we will come to know about some of the physical properties or physical character of acid, then how acid reacts with metals, how acid reacts with metal carbonates, metal bicarbonates, metal oxides, then ultimately how acid reacts with a base, etc. So we will continue our discussion. I will write the key points on the board. Similarly, you have to note it down in your copies. Then we will also write down some of the key and very important chemical reactions in the blackboard, and what you have to do is to copy the same thing in your respective chemistry copies. Okay, so we will continue our discussion. We will start our discussion, that is properties of acid. Okay, I will write down properties of acid. You also have to write down in your copies. So this will be the heading, properties of acid. Okay, properties of acid. So first property that we learned in the last class was that acids are those substances which have a particular kind of taste. And what was that taste? That is sour taste. So first point we will write over here, that is acids are generally sour in taste. Number 2, you have to write, that is acids dissolve in water to release H plus ions. We have discussed it already that acid need a medium, and that medium is nothing but water. Okay, if there is no water around an acid, the acid cannot show its acidic nature, because you know this ion, H plus ion, is not stable on its own. So it needs someone to make itself stable, and that is the water molecule. It will combine with the water molecule to give us the H3O positive or the hydronium ion, as we have discussed in the previous class. So I think there should be no issue, there should be no confusion regarding this. Then the third point you have to write, acids turn blue litmus into red. Okay, acids turn blue litmus into red. Again you have to write, acids make phenolphthalein colorless. PHENOLP, then PHALEIN, phenolphthalein. This is one of the indicators that we have discussed in the previous class, phenolphthalein. So these are the 4 key physical properties, or you can say physical character of acid. Okay, now we will discuss how acid reacts with different substances. Okay, so this will come under this heading only, nothing new, the same heading, but here you will write one small subheading, that is reaction of acid, so that it is easier for you to understand. That is reaction of acid. Reaction of acid. That is the main heading and this will be the subheading. Reaction of acids. So under this particular subheading, first point will be acids reacting with metals. First reaction of acid, that is acid reacting with metals. Okay, so the points will be written here because there is no space left. So here I will write the points that is supposed to be written here, now will be written here. You just continue. So acids reacts with metals. Acid reacts with metals to give hydrogen gas written hydrogen gas and metal salt. Acid reacts with metal to give hydrogen gas and metal salt. Then, so this can be summarized by a reaction which you can write like acid plus metal gives metal salt plus hydrogen gas. So this is a generalized equation. You just write it down like this. So after that we will give some example. So I have written two examples for you, this one and this one. So in the first example we can see that this is a reaction of zinc metal with sulfuric acid. So when zinc reacts with sulfuric acid, it gives us two products. Okay, so this side is for product, this side is for reactants. So in the first reaction, zinc reacts with sulfuric acid to give us two products. One is metal salt, zinc sulfate, and the other one is hydrogen gas. So in this kind of reaction, when acid reacts with metal, the products are almost fixed. That means one product is always going to be hydrogen, while the other product is always going to be the metal salt. No matter what kind of acid, what kind of metal you are taking, but the product will always have two types. One will be the hydrogen gas, which will be evolved out of the reaction, and the next one is the metal salt itself. So similar to the first reaction, we have the second reaction in which we have magnesium and we have hydrochloric acid or HCl. So when these two reactants combine, it gives us two products. One is metal salt, magnesium chloride, this is metal salt, and this is hydrogen gas. Okay, but as you can see, the second reaction is not balanced. Can you see? One magnesium here, one magnesium here, one chlorine here, but we have two chlorine over here. We have one hydrogen on this side, we have two hydrogen on this side. So whenever you observe this kind of reaction which is not balanced, first of all you need to balance them up. So in order to balance it, you just have to put a 2 here and everything will be balanced easily. Okay. So the main thing that you have to remember from this particular reaction is whenever acid reacts with metal, it gives us two products. One is the metal salt, one is the hydrogen gas. Okay. And there is one more thing I would like to share with you all is, if you remember from the first chapter, then we came to know about different kind of reactions. We had addition reaction, we had displacement reaction, we had combination reaction, we had double displacement reaction, we had redox reaction, etc., etc. So what kind of reaction is it? This one and this one. What kind of reaction? So if you observe closely, then you will see that in both these two reactions there is displacement. Displacement is happening. So zinc and magnesium. Okay, so first of all you observe here, zinc is slowly replacing hydrogen. So now initially hydrogen was with the sulfate group SO4, but when the reaction proceed, this zinc, it came in place of hydrogen and it displaced hydrogen. So now as a result, this hydrogen has been shifted out of this particular compound and zinc sulfate has been formed and hydrogen gas is evolved. So this is a kind of displacement reaction. Since the displacement is done by a metal, so this will be called metal displacement reaction. So that is why I told you that all the chapters are related and you need to have the proper knowledge of the previous chapter in order to understand this equation and these reactions. Now we will move on to the next type of reaction, that is number B, and number B will be acid reacting with metal oxides. Acid reacting with metal oxides. So this will be point number B. I hope you have written both the equations and you have balanced the second equation, and now you have the proper knowledge about the sequence that happens when acid reacts with a metal. Okay, so the two products that is formed, and that is always true, and you have to remember that whenever acid reacts with metal, it gives us hydrogen gas and metal salt. Now let's move on to the second reaction, acid reacting with metal oxide. So you write down. Okay, so before writing the definition of this type of reaction, what is metal oxide? You need to have the knowledge of this. What is metal oxide? CaO, calcium oxide, MgO, magnesium oxide, ZnO, zinc oxide. These are all oxides. To be more precise, what kind of oxide? Metal oxide. Because calcium is metal, magnesium is metal, and zinc is also metal. That means whenever metal reacts with oxygen to form a compound, that is called oxide. You have to remember that much only. That is in very easy sense. Okay, that is in very easy sense. That is, whenever metal reacts with oxygen, it gives us metal oxide. Okay, however, the reaction does not happen that much easily. That is a different set altogether, but that is not required as of now. So whenever metal reacts with oxygen, it gives us metal oxide. Okay, that much is clear. Now listen carefully. Metal oxides are said to be basic in nature. Basic in nature. So the metal oxides that I have just written here just now, all these metal oxides are basic in nature. This is the character of metal oxides. They have some basic nature within themselves. That means whenever they get the opportunity, they will act like a base. Okay, that is why they are said to be basic in nature. Now the thing is, when acid reacts with such metal oxides which are basic in nature, they gives us two products. Okay, they gives us two products. One is salt and the next one is water. Okay, now you write down along with me. Acid reacts with metal oxides which are basic in nature to give salt and water. Okay, so the definition says acid reacts with metal oxides which are basic in nature to give salt and water. Okay, so basically these metal oxides are basic in nature. They have some basic properties within themselves, and whenever they react with acid, it gives us salt and water. Now we will write two examples in order to understand. Okay, we will write two examples. Let's take metal oxide like calcium oxide. Okay, and let us take any acid. Say let's take HCl, hydrochloric acid. Calcium oxide plus hydrochloric acid. So we have one metal oxide, this one calcium oxide, which is basic in nature, and we have one acid with us, which is HCl, hydrochloric acid. Now when these two reactants combine, it will give us two products. Okay, already given in the definition, and the two products are salt and water. So we know one of the product will be water anyway, so there is nothing to worry about, and the other product is salt. Now when calcium oxide reacts with hydrochloric acid, it gives us what kind of salt? It will give us calcium chloride, CaCl2 plus H2O. Okay, CaCl2 and H2O. Now tell me, if the reaction is balanced, we have one calcium here, we have one calcium here, nothing to worry about. We have one oxygen here, we have one oxygen here, that is also balanced. We have one hydrogen here, but we have two hydrogen here, that is not balanced. We have one chlorine here, we have two chlorine here, that is not balanced. So in order to make the things balanced, in order to make the number of substances on the left side equal to the number of substances on the right hand side, we need to make certain changes, and that change will be adding or giving a 2 here. Okay, so now calcium oxide plus 2HCl gives us CaCl2 plus H2O. Correct? Now the equation is balanced. Let's write one more equation. Let's take magnesium oxide, MgO. This time let's take a different acid. We have already taken HCl, so we will not take HCl again. So this time let us take, say for example, H2SO4, H2SO4, sulfuric acid. So what kind of salt we can expect? Magnesium oxide when reacts with sulfuric acid, it gives us magnesium sulfate. Salt is magnesium sulfate, MgSO4. And yes, the other product is quite obvious, that is water and H2O. Now you tell me whether the reaction is balanced or not. Count the number of products and reactants on both the sides. What do you see? one magnesium here, one magnesium here, one oxygen here. Total 4 plus 1, 5 oxygen. Here also we have 5 oxygen. We have 2 hydrogen here, we have 2 hydrogen here, 1 sulfur here, 1 sulfur here as well. So the reaction is balanced. Okay, so this is the second type of reaction of acid. First one was when acid reacts with metal. Second one is when acid reacts with metal oxides. And now we will learn about the third type of reaction, that is acid reacting with metal carbonates. While writing the third type of reaction for acids, we have to keep in mind that in the third category, that is in this point C, we will show reaction of acid with both metal carbonates and metal hydrogen carbonates. Okay, carbonates and hydrogen carbonate or bicarbonate. Okay, so if you take a look at your textbook, there also they have grouped the reaction of acid with metal carbonate and metal bicarbonate under the same category. So we will also keep the reaction in the same category. So we will be writing acids reacting with metal carbonates and metal bicarbonate. Okay, so metal bicarbonate are also called metal hydrogen carbonate. Okay, so carbonate, before starting, just let me give you an idea. Carbonates are CO3 2 minus. That means their valency is -2. CO3 2 minus. And bicarbonate or hydrogen carbonates are HCO3 minus, and they have valency of -1. Okay, so there is a difference of one hydrogen atom between carbonate and bicarbonate. Carbonate means CO3 2 minus and bicarbonate means HCO3 minus. Okay, now let's see how metal reacts with acid reacts with metal carbonates and bicarbonates. Okay, so you write down acids react with metal carbonates and metal bicarbonates to form corresponding salt, comma, carbon dioxide gas and water. Okay, so write down this. Acids react with metal carbonates and metal bicarbonates to form corresponding salt, carbon dioxide and water. So this time we are having three products with us. Okay, now let me give you some example. Let's take example of so what is this? Na2CO3. Clearly this is one carbonate because this is CO3. But what carbonate? This is sodium. Sodium and carbonate, so this is called sodium carbonate. So we have sodium carbonate and we have HCl with us, HCl hydrochloric acid. So when acid reacts with metal carbonate or bicarbonate, we are going to get the same kind of product. Whether it is carbonate or bicarbonate does not matter, but the type of products that we will be getting will be of similar type. So as we have written, whenever acid reacts with metal carbonate, it gives us corresponding salt, carbon dioxide and water. So we will be having three products. One is corresponding salt. What is the meaning of corresponding salt? So corresponding salt means when this metal carbonate reacts with this salt, with this acid, it will give that salt which will result from this and this. The salt can not come from anywhere else. The salt cannot come from anywhere else. The salt must have to come from this one and this one combined. So whenever this reacts with this one, it will give us NaCl, that is the salt. Then we have two more products, that is carbon dioxide gas, that is CO2, plus we have the third product, that is water. Okay, NaCl plus CO2 plus H2O. Now tell me whether the reaction is balanced or not. Obviously the reaction is not balanced, correct? We have two sodium, we have one sodium here, so not balanced. So we will add 2 here. So as soon as you add 2 here, number of sodium is balanced and number of chlorine is not balanced. We have 2 chlorine here, we have 1 chlorine here. So add 2 here as well. Now count. We have 2 sodium balanced, we have 1 carbon balanced, we have 3 oxygen and 3 oxygen balanced, we have 2 hydrogen balanced, we have 2 chlorine and we have 2 chlorine balanced. So this is one example where we have shown the reaction of acid with metal carbonate, and now we will write another reaction where we will show reaction of acid with metal bicarbonate. So let's take similar bicarbonate of the same metal. We will take sodium bicarbonate, NaHCO3. Okay, so this is bicarbonate and this is sodium. So this will be called sodium bicarbonate. Sodium bicarbonate plus H2SO4. This time we are taking a different acid. We have taken sulfuric acid. NaHCO3 plus H2SO4. It will give you Na2SO4 plus CO2 plus H2O. Okay. Now again the same thing, you have to balance. 2 sodium here, we have 1 sodium here, so let's balance it. Now we have in total 4 hydrogen, 2 from here, 2 from here, and we have only 2 hydrogen. So to make the balance, what you have to do? Two here. Okay. So I have balanced the equation for you. 2 sodium here, 2 sodium here, 2 hydrogen here and 2 hydrogen here, that is total 4 hydrogen. Here we have total 4 hydrogen. Then we have 2 carbon here, we have 2 carbon here. We have in total 2 3s are 6 plus 4 10 oxygen. Here also we have 4 and 2 8. Yes. So the number of oxygen, yes, you need to balance the number of oxygen here. Okay. So you can count the numbers yourself. 2 sodium, 1 sulfur, 1 sulfur. Then we have 2 carbon here, we have 2 carbon here. We have 4 hydrogen here, we have 4 hydrogen here. Okay, then we have 1 sulfur here, 1 sulfur here. And total number of oxygen is here 2 3s are 6 plus 4 10, and on this side 4, then 5 6 7 8 9 10. Okay, so I think this much is enough for today's class. So the remaining reactions of acids will be discussed in the next video, in the next class. And after finishing the properties of or the reactions of acids, we will revise the topics, we will revise the contents in a live Zoom class. Okay, so everything that has been taught till this point, note it down and prepare a nice note yourself in your respective chemistry copies. Thank you.